Now let's add an edge. We will watch exactly what changes inside each representation. Let's add the undirected edge between vertex 1 and vertex 4. In a matrix, one edge means writing two cells. If you write only one, the graph quietly turns into a directed graph. Step 1. We set him at row 1 column 4 to 1. This green cell is the right. Row 1 now shows the edge to vertex 4, but row 4 does not show it yet. Step 2. We set him at row 4 column 1 to 1. This second green cell is the mirror right. Now M at row 4 column 1 matches M at row 1 column 4, and the matrix is symmetric again. This is the same operation in C, it is just two array rights, so we skip the pseudocode. The function addEdgeMatrix takes the graph and the two vertices, U and V. This line sets G arrow matrix at U times G arrow and plus V to 1. That is the cell for the edge from U to V. This line sets the mirror cell. From V back to U it is easy to forget, and forgetting it is the classic bug. Both writes take constant time, so add edge on a matrix is big O of 1, no matter how many edges already exist. Now the same edge, but on adjacency lists. Here one edge means pushing a new node onto each endpoint's chain. Step 1. We push a node onto the chain edge at index 1. The new node holds to equals 4, and it becomes the head of vertex 1's chain. The green node is the new one. Step 2. We push a node onto the chain edge at index 4. This node holds to equals 1, and it becomes the head of vertex 4's chain. Now both sides record the edge. If you forget the second push, the edge shows up from vertex 1, but is invisible from vertex 4. That is the same bug as the matrix version. This is the list version in C. It is two head inserts. The same splice from the linked list chapter, done twice. The function addEdgeList takes the graph and the two vertices. First it calls xmalloc to allocate one edge node, called A. It sets a arrow to equal V, points a arrow next at the current head G arrow edge at index U, then makes of the new head. So V joins U's chain at the front. Then it allocates a second node called B for the other direction. It sets B arrow to equal U and splices B onto the front of G arrow edge at index V, so U joins V's chain. Two mallocs and two head inserts, no walking, so add edge on a list is also big O of 1.